Radical equations is going to be what we take a look at here in this session. Basically, a radical equation is just any equation that has a variable somewhere in it that is within a radical sign or a square root sign. If that happens, you have what's called a radical equation. Oftentimes, one of the strategies for solving a radical equation is that you end up squaring both sides of the equation. But you need to understand that by doing that, sometimes you'll be introducing an answer that really does not solve the original question or the original problem. As a quick example, let me show you a very simple form or a very simple equation. X equals 7. Well, let's say if I wanted to go ahead and square both sides. So I'm going to square the left side and I'm going to square the right side. What I now have on the left side is x squared. And what I have on the right side is 7 squared, which is 49. But now let's say I wanted to say, what are the values for x when you square them that equal 79? Well, we actually have two answers here, 7 and minus 7. Minus 7 squared is 49. Well, what was our original problem? Our original equation was x equals 7. But by squaring both sides and then working backwards, we not only got 7 as an answer, we got minus 7 as an answer. And once again, the reason for that is whenever you create a square or have something squared, you now introduce a negative number as being a solution to that may not necessarily fit your original equation. So once again, whenever you have a radical equation, always take the answers that you come up with and double check them back with your original equation to make sure that they both work. With that in mind, let's go ahead and take a look here at this equation. The square root of x plus 4 equals 5. Is this a radical equation? Well, yes, it is, because we have a variable somewhere within a radical sign. And that's our definition of a radical equation. Now, in order to solve this, once again, as a general rule for algebraic problems, we always try to get the variable that we're trying to solve for all by itself on one side of the equation. Well, right now, it's crammed on the inside of a radical sign with a 4 that it's being added to. We can't just simply separate this and say that the square root of x plus 4 is the same thing as the square root of x plus the square root of 4. We've already shown on previous sessions that that doesn't work. This radical sign is a problem. How are we going to get rid of this radical sign so that we can then more easily deal with the x plus the 4? Well, what we can do is actually square both sides. So I'm going to take the left side and square it, and we're going to take the right side and square it. Now then, what is the square root of x plus 4 to the squared to the second power? Well, it's just simply x plus 4. And that's going to equal 5 squared, which is 25. Now we can solve it for x. We subtract 4 from both sides. That's going to leave us with an x on the left side, and 25 minus 4 leaves us 21 on the right-hand side. So we get an answer here of x equaling 21. Well, let's go back to our original problem. Remember, our original one did not have the square in it. It was simply the square root of x plus 4 equaling 5. Well, let's stick a 21 back in there. 21 plus 4 is 25. What's the square root of 25? 5. Does 5 equal 5? Yes, it does. So x equals 21 is the solution to our radical equation here. Next, we'll take a look at one more. The square root of 3x minus 8 plus 6 equals 16. Now, once again, we have a radical equation. We have a variable underneath or within a radical sign. The first thing we want to make sure that we do is that we get the radical sign that has the variable within it by itself on one side of the equation. Well, right now, it's being added with a 6. So what we need to do is subtract 6 from both sides. What that'll leave us with on the left is radical 3x minus 8. By subtracting 6, that cancels out with this positive 6, leaving us 0 there. And then we subtract 6 from the right. 16 minus 6 is 10. That's our first step. Are we now left with the x all by itself within one radical sign? Yes, we are. So at this point, we can then go through our strategy now of squaring both sides of the equation. The square root of, or radical 3x minus 8, squaring that is simply 3x minus 8. Squaring 10 on the right side gives us 100. Now we continue to solve for x. We need to add 8 to both sides, so that's going to leave us with 3x on the left and 108 on the right. We now need to divide both sides by 3. That's going to leave us with an x on the left and a 36 on the right. We need to double check our answer by putting it back into the original equation. So we're going to put a 36 back in here. 3 times 36 is 108. 108 minus 8 is 100. What is the square root of 100? It's 10. 10 plus 16 is 16. 16 on the left matches your 16 on the right. So x equaling 36 is the correct solution to this radical equation. And as a quick review, radical equations are equations that have at least one variable occurring within a radical sign within the equation itself. And then also as a reminder, when you're squaring both sides of an equation, it's possible that you'll be introducing a solution that doesn't fit the original problem. Because of this, always make sure you double check your answers by putting them back into the original problem to see if they work as solutions. That'll finish up session 86.